And so I am now recording.
Yep.
How do I know that? Back up
It
here.
would just be on there.
I see it says stop recording. Okay.
So it's not super.
Okay. The time is 9:54. This is the scheduled meeting of ITSE 2309. Stephen Smith speaking. And we'll begin here in about 3 or 4 minutes. I have opened it for meeting. In other words, I sent out an announcement that had my personal meeting identifier in it, and so you can join the meeting if you have Zoom on your computer. Now, I don't think these Collin College machines have it for the student stations. Just sometimes we get feedback from it. If you have Zoom on your home computer, it's free to install, and you can live stream from sitting at home. And after I've finished the class portion of this, somebody just joined. After I finish the class portion, I will go to a chat and see how that works. So I'll be holding office hours. I also have office hours. I sent a announcement on that. I have office hours at Spring Creek campus in J122, Tuesday and Thursday from 11 o'clock till noon. You may bring your laptop, but I cannot install anything on your laptop. Is that somebody in here that's joined? Karina? Okay. About 2 minutes and we'll begin. Okay, where am I getting that from? Let's see, somebody has a hot mic. Is it me? Okay, I have 10 o'clock sharp. We're going to begin. This is the scheduled meeting of ITSE 2309 at Collin College. And today is the 8th, I believe, September 8th. Okay, today we're going to be in Module 3. Now, there are some questions about what did we turn in on Module 2. Module 2 was getting your SQL server up and running, hopefully get familiar with the interface. There wasn't a great deal to turn in Module 2, but I need something to be turned in because because I'm coming up on the date that I have to certify my roster. So that means I need something from everybody. Okay. So Module 2, the assignment was, well, the assignments were reading and then do some things on the with the interface. Send me a note that says you did it, and I gave you the 5 points or whatever it was. And so basically, I need to, that's an assignment you've turned in, so you've demonstrated that you're physically present and active in the class. That's really all I needed. Module 3 is where we're going to get started here. Module 3, I'm going to move ahead a little bit in it, and we're going to go up to creating tables in SQL. Now, the textbook puts creating the tables up in Chapter 7. So it just starts out with the SQL. And I think it's important to learn about what a table is and how you create a table. So SQL, I pointed out, is an ancient language as computer languages go. SQL is ancient. SQL goes back probably to the 60s at least. So it's called structured query language. Some people call it SQL. SQL has two pieces. There is a part of SQL that is a series of commands. Create a table, create this, create something else. So it's a command that you give the system, and it creates a table. It makes the table, and the command is create table, followed by the table name. There is a syntax of it, but first we need to talk about what is a table. See if I can. Okay, the demonstration file is Module 3, Create 1 SQL, and this is the download link right here. I'm pointing to it with the mouse on the screen. I believe I'm captured. Is somebody here, Karina? Who's Karina? Okay, are you seeing this okay? Okay, so I'm gonna, we got somebody here zooming. So this is the demonstration script, and I'm going to right-click and say Save Link As, and let me put it into, I guess I'll put it in my downloads. Save. Now, I highly recommend that you get this little, find it here, Notepad++, LMN. Notepad++. Notepad++ is a free little text editor. Very nice one for doing SQL. It'll do any programming language. Now, it is not tied to the programming language, meaning that it will not execute the code for you. So if you're in C, you don't have a little button that says, okay, compile, and another one that says execute. Similarly, in SQL, if you're working in Notepad++, you don't have the ability to say, okay, run the program. You have to go back over to the management studio to do that. But it is nice because I can just open the file easily. I'm going to go to my downloads where I put that. I'm going to open the SQL. Now, the language, if you set the language as SQL and it recognized it was an SQL file, it will do all of the syntax highlighting for you. So this is pretty nice. And this is a demonstration script that creates two tables. Now, we talked a little bit about the three basic rules of database. And what were those? Anybody remember them? I gave you three rules, and but we call this in database the first normal form if it conforms to these three rules. What do you remember them from last time? Maybe not. But let me review them for you. First of all, they're in a table. So a table, think of a table, maybe you could think of a table as something like the rows in a spreadsheet. It's really not like a rows in a spreadsheet, but think of it as a table and think of it as rows and columns. So the columns are the fields. Yes, sir. Yes. Mm-hmm. No duplicate records. So no row in your thing that looks like a spreadsheet can be exactly the same in all fields. Each record in a database has to be unique. Okay. Second thing, we never access a database by talking about rows and columns. We only say, give me all of the records where the city is equal to Frisco. And the third piece of a database, which is kind of a design issue, a field must have exactly one value. Now, it's perfectly okay to have a field that says telephone numbers, but you shouldn't break that up and think of it as phone number 1, phone number 2, phone number 3. It can be comma separated words in there. That's okay, as long as you are treating it as a single value. Once you start thinking of it in terms of multiple values, it's time to break it out into a table of its own. And that's what we're going to talk about today, a table. Okay, a table, all rows in a table have to be unique. Since they all have to be unique, got my back to the camera, but that's okay, they'll get over it. Since they have to be unique, is there any single field that we can identify that will make that unique? And that's what I want. I want something like a social security number that I know is unique for every record. Now, we're going to have a problem with social security numbers in, a few years, I guess. What's our big problem going to be? We're going to run out, and we're going to run out pretty darn soon. Okay. Let me ask you this question about a social security number. Is it really a number? Do I add, subtract, multiply, and divide it? No. So, since it's not that, I'm probably going to use characters. I prefer character fields to to numbers if I'm not going to add, subtract, multiply, and divide. For example, your telephone number. It makes no sense to multiply two telephone numbers together. You don't get anything that makes any sense. Same thing for Social Security numbers. Okay. So I'm going to try to identify that thing, and then that unique piece of each record, and then I identify the other fields of it. For example, in an employee, might have a social security number, probably a name, probably an address. What are these things? Those are all character data. I might have numbers in there. I can have numbers. So, but they are different things from character data. Let's take a look at this create table. The first line, well, the first line of a database script really should be a comment that has your name in it. Now, notice the comment on lines 1, 2, and 3. I'm using there the style of comment that you're probably used to seeing from C. The comment begins with a / and an asterisk. After that, all lines are commented until you give it the asterisk / that ends it. So the comment begins on line 1. It ends on line 3. That is, and that is a multi-line comment. Okay. The other comment that you may have seen, and you may use either -- anything that comes after that is a comment until the end of that line. So that's about the only thing in SQL that a carriage return ends is that comment. You may use either form of the comment. So you're used to seeing this in other languages. For example, in C or Java, they have the same thing. They just use a different character is all. It's not a big deal. So multi-line. The first line of all of the scripts that you write should be a comment in either form with your name in it. Second thing, put in there, please put what assignment this is. So sometimes when I'm looking at them, I say, no, which one was this? Particularly if they kind of trickle in and I'm sitting there trying to grade it on the train, it's sometimes difficult for me to figure out what I'm looking at. Okay. The first executed line of a SQL script. What database are you using? Now, my database, for example, is named SW Smith _DB. DB Cooper, Database Cooper, is my demonstration user. I don't really have a database. This one won't run. I'd have to put my own database in there. So I would say either use SW Smith _DB. What database are you using? Now, we've set a default database. If we don't say use a database, we're going to use that one. But it is always good practice to say use the database. I'm going to ask that you do that. Okay. So the first line, first executed line after your name and a comment comes use the database. We will be using the accounts receivable, the, accounts payable, AP _DB. We've created that one. It's a database with a bunch of data in it. We're going to be using that one quite a bit. Okay. Which one are we using? Line 6. Line 6 is not a pure SQL statement. Line 6 is unique to SQL Server. Line 6 says go. Go where? Well, when you see, notice that go doesn't have a semicolon after it. If you put a semicolon after it, it wouldn't be wrong. You may or may not have a semicolon after the go. I won't enforce it one way or the other because it is not an SQL statement. Now, SQL Server will let you get away without putting semicolons after your statements. I won't. So if you want to just put semicolons after every statement, that's fine. But Go is not really part of SQL. You won't see it any place but SQL Server. What Go means is make all of that stuff happen. It breaks your script into multiple executable pieces, and it says, okay, finish that, and then start from clean. You will have to do it. There'll be places where you have to have it. In this case, it's optional, but I'm demonstrating the use of it. It's usually never wrong to have a go. Okay, execute that line and go. Usually you don't put it between every line because it does slow your process down a little bit. I put it between creating tables, I believe. No, I didn't put it between creating tables. Let's look at the first table. Create table, employees. Okay. Create table. Now, by convention in SQL, when the word is part of the SQL programming language. Now, notice that our Notepad has highlighted the syntax for us. Notepad ++. Now, if you could work in Notepad just fine. If you just want to work in Notepad, that's good on you. But you just won't get all this pretty colors of the syntax highlighting, as we call it. So when it recognizes something, it won't recognize everything. Some things you'll say, well, why didn't it highlight that? So you take a look at it, that's spelled right, everything. Okay, it just didn't. It's not a big deal. But when it does highlight it, that means it's a reserved word, and we will write that word in all capital letters. Now, SQL is not case sensitive. SQL doesn't care about uppercase, lowercase. But when it is a word that is an SQL, by convention, it is uppercase. The identifiers, for example, I have an identifier up there, employee. Some people will capitalize the first letter. Some people will write them in camel case. Okay. You never put spaces in an identifier. What, never? You never put spaces in an identifier. Why not? SQL Server will let you, certainly Access will let you do it, and I believe SQL Server will. This is a very bad habit to get into. It will come back and bite you later. No identifier ever has a space in it. No table name, no field name. Right now we have the table name. Some people use the underscore character. That's fine. Some people use camel case. If it's two words, they capitalize the first one, then lowercase, then capitalize the other one. Doesn't matter. That's a stylistic choice that you have, how you name them. My naming convention is that I name the tables. I like it when I can name my tables with a unique first letter. Now, we'll see that they don't all conform to this, but mine happens when I name a table. I would name it employees. I would try not to name another table that began with an E. Don't always get my way on that. But this is the table. Now, this particular table that we're creating on line 8 has two fields. It has a field, an E underscore SSN, E underscore name. I'm just keeping it short and simple. Okay. I could have had a E underscore birth date. I could have had E underscore salary. Salary would have been a number. Birth date would have been a date. Okay, so they're different varmints. This one just demonstrates a couple of fields. So think of it like an index card, and on the index card is a person's SSN and name. There's no order to them. I can see them in any order I want to. There's no order to the index cards, but they're just all together. Thing. Now I have something there that is unique and social security number. Notice how I named the fields. In the field, I picked up enough of the name, enough of the table name to identify that field if I see it later in some code. And we're going to see, actually, there's a whole nother class on coding. There's a whole programming language associated with this. Sometimes you'll see a field name different from in the table, and I like knowing just from that field name what table it belongs. Some database designers will design tables that have duplicate names across the table. So they might have another table with the name SSN in it. I personally prefer not to do that, but there's nothing inherently wrong about it. If they do it, they do it. When I do it, I like to be able to look at it and say, aha, that field comes from the employees table. Questions? In database programming, it is best. Now, I'm going to tell you some things about database that don't always hold in every database. They tend to vary across database platforms. The big ones are Oracle, SQL Server, and MySQL. Different databases will behave slightly differently. It is best, notice line 12 has a comment on it. Okay. I wanted to skip a line. It is best if inside of an SQL statement, this is an SQL statement, inside of an SQL statement, it is best if you have no completely blank lines. Some platforms will twitch out on that. SQL Server won't have a problem. We're going to adopt the convention of no completely blank lines, because if we do that, then our SQL code will be able to pick it up and drop it into another database platform, okay, like Oracle. Oracle doesn't like completely blank lines. Okay. Now, let's look at line 13. We're in module 3. Line 13 is a constraint. What is a constraint? Get this out of your way. If I say constraint, okay. Okay. No, it's not a constant. It's a restriction. Okay, think of it as a restriction. Restriction on this table, or a restriction about the data. Okay. Now, what am I saying there? Constraint, and I give it a name. So the first word in that line is, this is a constraint. Next one is its name. Now, notice how I named it. When I named that constraint, I put the table name, underscore, and something that lets me know what it means. Now, PK, this file is available to you on Canvas, by the way. PK will mean primary key. And so it's just one of those things that it does. So primary key is ESSN. It is possible to have two fields in there, so it's possible to have a two-field primary key. I prefer not to, but sometimes I'm stuck. Sometimes I have to. What am I saying when I'm saying something is a primary key? One, it is required. Unique. Required and unique, meaning it cannot be null. We have a saying in database, nothing gives us lots of trouble. What am I talking about? Nothing, those nothings. A field that is nothing. We don't like those because they tend to be difficult to deal with in the process. I'm going to talk more about nothing. Let's talk about nothing. Anyway, it has to have a value. Right. Yeah. And that value has to be have value. The value has to be unique in the table. And then the second constraint there is that check that the e-name is not null. So null is the word we use for nothing. You cannot use any form of equal, not equal, greater than, less than to null. I cannot say check that e-name does not equal null. Okay, using the does not equal operator. It's less than, greater than together. I'll talk more about that. So the only thing I can say, the comparison for null is the word is. So check the e-name is null or check e-name is not null. The is the way you test for nothing. Okay. I can't say equal to. If I put an equal sign in there, it doesn't give you an error, but it is a logical error because equals means is the same thing as, and null is not a thing. So null, I'm not sure whether null equals null or null does not equal null, but one of them is always true. So if you say equals null, check that e-name does not equal null, I think it'll always be true, no matter what. It checks to make sure there is a name there. Okay, so it doesn't know anything about whether it's a valid name. It doesn't have to be unique. You just have to have one. Now, the other real weird thing about database is that a name, you can have a name that doesn't have any characters in it. Well, what's my name? I have a name. It's the name with no characters. That's different from not having a name. That's a string of zero length. I'm going to talk more about that. Some of you have done access. If you remember when you set up your table in access, one of them was required yes, no, and one of them said allow zero length. Okay, so you can have a string of characters in database that does not have any characters in it, but that's not null. That's different. And boy, that's something that gives a lot of people trouble because it's sometimes it's very difficult to see it. You'll be looking at the data, you say there's nothing there. Well, yeah, there is. There's a string with no characters there. Anyway, let's take a look at the types. ESSN is a char field, char 9. I'm allowing 9 characters. Well, shouldn't I allow 11 for an SSN? Doesn't it have dashes in it? I don't have to store the dashes. I can put them in later. Yeah, they're always in the same place. The other thing about an SSN, right now, I would start thinking about what your database is going to do when we run out of numbers for Social Security numbers. We probably will, I'm betting in the next 5 years, we do something with that. Question? A grid, please. What's that? GUID? I don't know that name. Oh, yeah. I think we're going to do that. I think we'll probably go to letters and numbers, and that will mean that we don't have to expand the field. So that will give us trouble because lots of times they have a constraint in there that checks to make sure that it's all numbers. But that's pretty easy to take off. It's a lot easier to take it off than it is. Notice that I gave it 9 characters. Okay? It is bad to have a field that is too large. It is disastrous to have a field that ends up being too small. A field that is too large, let me get back. You had a comment? Uh-huh. It overflowed, yeah. It shouldn't have crashed, but right. All integers will overflow. We're going to talk about that. There is a limit to an integer. What happens when it gets to its big. This is very definitely a thing with database. Okay. SSN char. Now, when you set a field as a char, C-H-A-R data type, and you say 9, it has 9 characters in it. It always has 9 characters in it. And you can put fewer than 9 characters in it, but it will always treat it as a group of 9 characters. So if you only put 4 characters in there, you're going to have 5 of them that are just empty. It's okay, that's not null. It doesn't hurt anything particularly. It is wasted space. What happens if I make it too small? Now we've got a problem. Suddenly I need more. I'm going to have to go in and rebuild that whole database because this thing, everything is set up. The data are all packed in there at 9 characters, and now all of a sudden I need 11, and I have 50 billion records. That means all of those records are going to have to move over just a little bit, each one. So I'm going to have to stop, shut down the database, and rebuild that whole table. That could take hours. Okay. So it's considered always make that field big enough. Make it just big enough to allow for growth in the future. I would start thinking now about giving it a couple of more characters. I might start giving it 16 characters. The other point about the size of these character fields is the database likes allocating on powers of 2. If you can give it a power of 2, that is good. Now, I wouldn't necessarily go up to a power of 2 just because if I were fairly sure I was always going to be under that. But a power of 2 gives you a good allocation space. I don't like 9. That's 1 over 8. 8's a power of 2. I like 8, 16, 32, if I can. So I will choose 16s and 32s fairly. If I can't get a power of 2, I like a multiple of 8. So Why would I like a multiple of 8? Well, it's close. It's something like the power of 2 because it's going to try to allocate in those blocks. Char. I prefer, okay, we're going to talk more. Now, the next one is varchar, V-A-R-C-H-A-R. Some people call it varchar, varchar. What do you think that is? V-A-R. Variable character field. That one can grow and shrink. So the amount of space it takes up in your database is can vary. Okay. Which of these do you think would be the best? That's a trick question because it never has an answer. Best for what? Which is the best tool to have, a hammer or a screwdriver? Depends on what you're doing. Okay, yeah, I agree. And with computer science, it's you get a lot of that kind of stuff in it too. A char field is cheaper in terms of using it. If I know how big something is, I know how big your social security number is, it's always going to be that size for everybody. I like a char field. If I have a small field, like 16 characters or something like that, I will use a char field because it is faster. A varchar field has to allow it to grow and shrink. That growing and shrinking does not come free. So if I were setting up a person's name, that's not big enough to cause me to go to a varchar field. I'm not going to use varchar unless I have 300 or 400 characters in there, usually. If I know that people's names tend to be probably 12 characters on average, I'm guessing. So I make it a little bit bigger than that, and I just say, okay, I'm going to allow 16. Okay. So it's always going to show you 16 characters, and it will just pad it out with spaces. If I get over 16 characters, it just chops it off. Anybody with a name longer than 16 characters is probably used to it. Pretty common. Okay. Questions? Now, some things about that. Notice that each line within the statement ends in a comma. So SSN, what it is. It's a little bit backwards from if you're used to C. If you're used to C, you put the type first and then the name. So it's the name, then the type, comma. Name, then the type, comma. The constraint name. Let's talk a little bit about these constraints. If you hit a constraint, if you violate a constraint, that will be an error. Your database will stop. You will get an error in your SQL, and that's okay. Error messages are your friends. But if you do not name the constraint, and I'll show you that you can set a primary key without putting a name to it. If I violate that constraint on line 13, I will see that name. I very rarely ever type that name again. I'll probably type it once, and I'll probably never type it again unless I'm disabling it, or I can take some constraints I can take off and say, okay, ignore this one for a while. Primary key, I cannot. So I will tend to make the constraint name. Let me point with my mouse. The constraint name, employee PK, I tend to make these verbose, long. I want them to have information. I want them to tell me what table it came from, what table, and something about what it does. Now, I'll use abbreviations, but notice that constraint, null e name. I might have prefaced that with employee underscore null underscore e name. E-name not null, something like that that tells me what it is. You may adopt your own convention on that. But when I see, I will get for my reading pleasure, if I hit that error, if I violate either of those constraints, for my reading pleasure, I will see the name of the constraint in the error message. SQL is famous for having very cryptic errors. There's so many of them. So they tend to be something like error 37591772 at line such and such. What the heck is that? I don't know. You could. Actually, there is a table in your database that would tell you that you could look up that and find out what it meant. But I'd rather just see it. I'd rather see it in the error message. Aha, I see employee underscore PK violated. Oh, I know what I did. I either didn't have a value there when I'm trying to put it in, or I did something that would have caused a duplicate. Brought me to a screeching halt, and I know why. I know how to fix it. So I will tend to make these, it's okay to, I tend to make my constraint names verbose. It's okay to abbreviate. Okay, don't abbreviate too much. But for example, first name is very frequently F name, L name, first name, last name. It's very frequently done. Questions? Okay, what were our rules? No duplicates. Okay, SSN, we've got that. Nobody can have the same SSN as anybody else. It's going to give us a problem because we can't reuse them. If somebody passes away, i.e. dies, we can't reuse their social security number because if I gave it to you, you'd be them and then you'd be dead. So we can't reissue them. No duplicates, access by content only. Give me the names where the employee name is Jones, and I get a list of them. Find the employee whose SSN is 1234, and I get a list of them. Okay. Question. And then finally, one and only one value. So name, if I just put name and your name was John Doe, I would be looking at that. I'm going to treat that as one single value. I'm not going to break it out and say, find me the one where it where the last name. Now, can you do it? Yes. But I'm claiming that when I set a field up as just name, I'm claiming that I'm going to use it all together. If I want to have first name, last name, I need to have them split out. First name field, last name field. Okay. Does an employee, there we go, have, what else does an employee have? Well, an employee has a salary, an employee has salary. Employee just has one salary. That's okay. Employee has a department. Just one salary is probably a number. Department. ID number. Yeah, it might be different from the social security number. In that case, I'd have a choice of which one I wanted to use as the primary key. Yeah, pick one and use it. Location of work, probably coded. Probably like location 1, 2, 3, 4. And over in another table, I'd find out what those were. IQ, number. Shoe size, number. You just got one of them. I'm looking for what might an employee have that they might have multiple of. Hint, hint. Look what I've highlighted up there. What does that say? Okay, well, dependents would be your family. Let me roll that up a little bit. Okay, dependents. How many dependents can a person have? It depends. Can you have 0? 1, 2, 3. Is there an upper bound? You're going to get in trouble with the IRS if you have 300 or 400. Okay, what's the most dependents you can have? Could we set an arbitrary limit? I suppose. And then somebody would show up that had more. How could we handle that? Well, I could have multiple records And so I could make the primary key be your social security number and your dependent's social security number. And then I could just insert multiple records for you. That's called redundancy. You know, I have your name duplicated many places. I don't like that because now one, I have more than one field in the primary key. You see what I'm saying? Make the primary key be your social security number and your dependent's social security number. It has a problem. What happens if you don't have any dependents? Now, I guess I could just put a null, a 000 in there, but I can't have a null anywhere in that primary key. Second thing is I'm duplicating your name multiple places in that database. I don't like to have that anytime in a database that I have redundancy. That's bad. So the other thing I could do, I could put a bunch of fields in here, you know, dependent 1, dependent 2, dependent 3, dependent 4, and as many as I thought you were going to have. The downside to that is I'm going to have lots of null values. I don't like null values. So most people are only going to have 1 or 2 dependents. So most of them, if I allow you to have up to 10, most of my fields are going to have 8 or 9 null entries in them. I don't like that. This is the way we do it. This is what we mean when we say a relational database. So this is the example of 2 related tables. Notice that employees and their dependents are related. I fuss a little bit about the order of it. Now, notice that the D is the dependents table. So what do I have? I always put the first thing that I type always. Now, it doesn't matter what order you list these in. Well, it can, but right now, let's say it doesn't. You list them in any order you want to make your fields. I always put the primary key as the first field I name. That's the most important one, because this is how your data will actually be ordered on the disk. This is the fastest way to access your data is by the primary key. Okay. After that, I just name them in any order. Some people alphabetize them. I don't worry a whole lot about it. Okay. Some method to my madness here. My first one is the primary key. So the primary key is the DSSN. Notice that it begins with the first letter of the table name. Dependents table, my DSSN, D name, and so on. Very similar to the employee table, except then we find one that doesn't match. Here it is, on line 21. Suddenly, here's one that doesn't match, and that calls your attention to it. Why is that one important on line 21? Right, I'm creating the relationship. Or I haven't gotten to that yet, but I'm about to here in another line or two. Okay, what table am I related to by just looking at that name of that field? What does it belong in this table? Well, yes, it does. But do the data come from this table? No, they come from which table? The E table. Okay. So this is why I like that naming convention. All I have to do is look at the names of those fields, and I can tell you right that field, because of its name and its location in that D table, is what we call a foreign key. Takes me to another table. A foreign key is usually, virtually always, the primary key of its parent table. And we talk about it, a parent-child. So the dependent is the child, the employee is the parent. So it references the parent table. Okay. I haven't yet created it. Right now, all I've done is named it. It must be the same type as its parent key. Okay. It should be the same name. It is not required that it be the same name. If it's not the same type, you've got a problem. Sometimes you might have two foreign keys to the same table. I might have two parents. So I might have parent number one, parent number two, and they are both in the employee's table. That's quite possible. In that case, I could not keep the name being the same. The name has to be unique within the table. But when I can, I make the name in the child table match the name in the parent table. Questions? I don't think we'll be. If you take my second class next semester, we'll have some tables where we just have to have ESSN1, ESSN2, or something like that. Are you talking about D name and E name? Well, they are two different. They're not related. So my name and my child's name don't have to be the same. And just by looking at my child's name, you can't tell that he is related to me. The way you tell is you look at my child's medical insurance card. It will have my number on it. That's how you tell that that belongs to me, and I'm responsible for whatever he does. I don't know about that. Okay. Constraints. Let's look at the constraints. The first constraint is the primary key. Goodness, 1046. First constraint's primary key. Notice it has the dependent, it's got the table name in it. Some people will name the tables in the plural. Some people will name them singular. I tend to say it's a good idea to do one or the other consistently. Have method to your madness. PK is primary key, and I say what it is. Okay. Where the rubber meets the road here. It is acceptable to break the line. If you break the line, I like it tabbed under there to show me, but visually, that that it's part of the same, that I haven't ended it yet, so that indenting under it, and then the next one would. So notice how there's a nice line down here. But if I have to break the line, if a line gets too long, I don't like them scrolling off the side of the page, so I will break them and indent. So visually, I see it as part of the same. Okay, let's look at that constraint. Constraint, give it a name. Notice that that one applies to two tables. The first one I put will be the name of the table where the constraint exists. This constraint is on the dependence table, so the constraint is named dependents underscore employees, excuse me, underscore FK. FK, foreign key. References, foreign key, ESSN, so I give it the name. This is the foreign key in this table, in the dependence table. I better point with the mouse because the people who are watching this won't be able to see me. So this particular one, foreign key, is this one. It's doing that highlighting. I guess I'll have to turn that off. So I'm talking about this ESSN. References, employees, ESSN. So the reference is up here. Now, what am I saying? When I say it's a foreign key, what am I saying about it? Okay. Yeah. We can say, for the purposes of this class, we can say it will always be a primary key. It does not absolutely have to be. You could conceivably reference a non-primary key. It would have to be unique in the parent table. So I'd have no which child. So you couldn't reference the parent name because that might be duplicated. So it has to be unique. So, for example, and you could use the employee ID if it were unique. If it were unique, if it were guaranteed to be unique, is it possible to have two people that share the same address? Maybe they're cohabitating. They could be significant others, you know. So it's quite possible. The other thing is it can't be unique by accident. It has to be unique by table constraint. It says this is unique. You can't have two of them. And we're going to talk about that. There is a constraint that I can put on it that makes it unique. Okay, I'm saying that it references that one. There's two things I'm saying. Do I have to have a parent? Okay, yeah, I have to have a parent. I mean, how'd I get here? In database, if I have a foreign key, does it have to, can that foreign key be null, is what I'm asking. Can I have a null value in this field, the ESSN of the dependent? Can I have a null value? The answer is there is no database rule. There is nothing about database that would be inconsistent with having a null value there unless there is another constraint that stops you. Okay, so for example, I have a check constraint up there on line 14. It says the name is not null. Unless I have one of those in the dependents table, that ESSN can be null. That's called an orphan in database. We call that an orphan. And we're gonna write some SQL select scripts. I say go through the table and find all of the orphans. Find all of the dependents that have no corresponding employee that they're associated with. In other words, where it's null. Look for null values in there. That is possible. But I don't know, maybe in your database design, maybe in your business plan, having null values is bad. I don't want null values. But just because I set up the table, just because I set a foreign key, does not mean that there has to be a value there. What it does mean, if there is a value there, then that value must exist in the parent table. Okay, no bogus parents. Okay, so if I say that this dependent belongs to the employee whose ESSN is 2345, that 2345 must exist. Otherwise, you will throw that constraint. Now, if you want to disallow orphans, you would constrain that field to not null, just like this. It would look a lot like this constraint right here, except it would say the constraint name has to be unique in the database, but it would be check ESSN is not null. That would say, and no orphans. So not only do they have to be, but to get that to throw out orphans, I have to constrain the database questions. Sometimes you allow orphans, sometimes you don't. It depends on your business model. What are you trying to do with this database? So if I say to you, a dependent has at most one parent, one sponsor, let's call it, at most one, how many can they have? They can have 1 or 0. In that case, I'm saying if I say at most 1, that means it allows orphans. What if I say exactly 1? You can only have. Okay. So a dependent has, if I constrain it, exactly 1. It must have a parent. Or in this case, as I wrote this one, a dependent has at most 1 parent. How many children can a parent have in this setup? Many as they want. But it's between them and the IRS. So as far as my database goes, they could have 1 million. It wouldn't stop anything here in the database. I would just have 1 million records that matched the ESSN. Could they have 0? Yeah, no problem. I have no duplication of data except for the foreign key. Questions. Now this is used other places. Somebody mentioned location a minute ago in the employees table. Who's location? Okay, location. Location is a fairly large field, I guess. What would that be? It would probably be an address or something like that. Maybe your business has multiple campuses, so maybe they're in different cities and they have many different. So location might get long. I might need to have 50 or 60 characters for that. What I would probably do with those locations, I would probably create a table. In that table, I would have location ID 1, now a long name beside it, location ID 2, and a long name beside it. And then I would have in my employees table, I would set up location ID as a field, referencing that parent table. In that case, the parent table would be the location ID. In that case, I would allow orphans because you might not have a location. Maybe you're newly hired. Okay. I don't like orphans. I don't have any problem with orphans. I don't like null fields in my database. So what I would probably do with the location table, I would probably have location 0, meaning unassigned. And when I put an employee in the table, I would just automatically give them location 0. And then later, when I decide what location to give them, I'm going to give them a different one. I can put it in automatically. If you don't give me one, I'm going to put in 0. And then I could constrain it at not have an orphan. So I would have the person who had location ID 0. By the way, doing that is called, sounds kind of a rude word, it's called POO, parent of orphans. So if I can put a field in there that is code 0. So for example, if I constrained this dependence against having orphans, I would probably put a employee record in there with the ESSN of 0000, one that I'm sure nobody can have. And then, gee, I've got a dependent here that does not have a sponsor. I'm going to put in that by default. That allows me to, I don't like, I tend to constrain everything as not null. And then I go back and open it up as I have to. Mm-hmm. If you don't give me a field, if you don't give me a location ID, you get location ID 0. And location ID 0, beside it has unassigned. So that's what I mean. What time is it? 11. I promised you a break at 11. Okay, I'm going to shut down the recording and let it go ahead. This will be part one. We will be coming back for part two of the class in a few minutes. So I'm going to go ahead and end the recording, and then there'll be, so you're going to have two links on Canvas like you did last week. And let's see.